So this is Nathan Smith, teaching economics in business for classes in Visalia and North Fresno, and I'm going over the notes, the slides from chapter 2 here, and so this is the heart of economics. This is brilliant. This is really the center of all of economics, the sort of the single greatest insight that economics has to offer, and which is really valuable. You may have seen it before because it's pretty much Econ 101. I mean, I think any economics class, any starting economics class, is probably pretty much the first thing they'll do. But okay, well, some definitions to begin with. A market, any institutional arrangement under which buyers and sellers can exchange some quantity of a good or service at a mutually agreeable price. Notice that this is a considerable generalization of the sort of physical idea of a market. You can think of a bazaar, a place where you've got a lot of merchants out there, selling their wares, calling it. I've been to bazaars in the third world, and you've got a lot of direct competition. You can see the competition right in front of your eyes. In advanced countries, we don't really have many markets in quite that sense, so this term is sort of more abstract. You don't go to the bazaar anymore to buy a bunch of goods. You don't go to the village market where you've got a lot of people selling their wares. You'll go to a big Walmart or something. It's one store. It doesn't have multiple sellers competing there, but just down the street there's a Target, or there's a Safeway, or whatever. So the competition, it's sort of spread out in space. It's not exactly as obvious, but it's still there. And so we use this in a sense a metaphor, but it's such a widespread metaphor that now it's just sort of the secondary meaning of the word. Is not a particularly physical location, but any kind of institutional arrangement where buyers and sellers can exchange some quantity of a good or service at a mutually agreeable price. And now we want to go a little further, talk about a perfectly competitive market. This term we'll revisit a number of times in the course, so if you don't totally understand it now, that's fine. It has a lot of ramifications, but the basic meaning is it's a market where there's so many buyers and sellers of a product that each of them cannot affect the price. Some of you see that price takers cannot affect the price of the product. All the units of the product are homogeneous or identical. Homogeneous, more technical term. Identical is what that means. It means there's nothing to distinguish them. You don't care which Apple, you don't care which Ford Fiesta you buy, they're all the same. Resources are mobile. By the way, in some cases there may actually be differences among the products, but we abstract from those differences and treat the products as homogeneous, even though there are differences which do matter a little bit to some people. For present purposes, we'll assume the products are all the same. All units of the product are the same. Actually, don't worry about resources or mobile by now. But knowledge of the market is perfect. I will focus a little on that. Knowledge of the market is perfect means that no seller can get away with selling it at too high a price. No buyer can get away with buying at too low a price. If knowledge of the market weren't perfect, then maybe some buyer and seller meet, and the going price in the market is $10, but the seller doesn't know this, so the buyer offers $8, and the seller's like, oh yeah, that's more than my cost, so I'll sell it to you, not knowing that he's losing $2 that he could have got if he went and looked around to sell it to somebody else. Well, we assume that doesn't happen. Knowledge of the market is perfect. So these are sort of perfect competition, sort of a background assumption in order to apply the ordinary demand and supply model that we're about to present. Okay, market demand schedule, market demand curve, these two are different ways of representing the same thing. So you can represent it as a table, listing a particular number. You can represent it as a curve, which kind of summarizes all the numbers and represents it geometrically. That will become clear in a moment. But market demand schedule is a table showing the quantity of a commodity that consumers are willing to purchase over a given period of time at each price of the commodity by holding constant all the relevant economic variables on which demand depends. So all other relevant economic variables hold constant. That's important. And it's the quantity that consumers are willing to buy at a given price. So the price, again, I mentioned that consumers are price takers, so they take the price as given, and then they decide how much they want to buy. So there's no negotiation going on here. They just take the price as given. Now the law of demand, and in economics sometimes we talk about laws, and usually they're not really laws. They don't usually always apply. They're kind of rough generalizations, but this one is pretty solid. It's very hard to come up with exceptions to this rule. There may be one, but law of demand, higher prices reduce the quantity demanded of a good or service. Not a big surprise here, kind of common sense, but it's an important concept, so we'll want to keep it in mind throughout. So, okay, this is the first chart in the course. We'll use quite a few charts in the course to represent lots of different things. So one of the skills you need to have and or develop, or have already and develop even further, is that of reading charts. On this axis we have price, on this axis we have quantity, PQ, more specifically price of hamburgers per unit, millions of hamburgers per day. The specific description of quantities, the specific description of prices will change, but this PQ, price quantity, that pretty much stays the same through a wide variety of models. So you want to kind of get used to that. There's a sense in which this chart is backward. P should really be down here, Q should be up here, because we assume that Q is a function of P, so usually if most in math, you usually represent Y as a function of X, Y would be on this axis, X would be on this axis. That's not how we do it. Q is on the right axis, P is on the left axis, so sometimes that can be a source of little counterintuitive twists in this model, but that's the convention. So what does each point represent? B, it's a price. So the position of B in the space represents a price and a quantity. $2, 2 million hamburgers per day. C represents $1.50, 4 million hamburgers per day. $1, 6 million hamburgers per day. And you notice that the law of demand applies. The higher the price, the fewer hamburgers bought. The lower the price, the more hamburgers bought. Quantity is inversely related to price. Demand is downward sloping. I just said the same thing in about 4 different ways. And again, each point represents something, namely, it represents a price and a quantity, and they're related to each other because the quantity represents the amount that customers are willing to buy if the price is set to 50 cents in this case. So that's the demand curve. Very important landmark in the course. You want to understand what that means. Okay, so changes in demand. Changes in demand are where the entire demand curve for a commodity shifts. So you notice you can get a change in what's called quantity demanded, a change in quantity demanded by moving along the curve. If the price, trick question, if the price falls, does demand increase? Answer, no. Quantity demanded increases, but the demand curve stays the same. That's so technical, not even economists always get it right, but it is an important, let me put it this way, they're not always scrupulous in using the language in that way, but it is an important conceptual distinction. And so a change in quantity demanded, a movement along the demand curve, is different from a change in demand, where the whole demand curve shifts. So causes of changes in demand, it could be consumers' incomes rise or fall, could be consumers' tastes change, they start to like the good more or less, related commodities could change in price, and then you could also get more consumers in the market. So these are all factors that could affect demand. Okay, this represents a change in demand from D to D prime, increase in demand. So you see the whole curve shifts. That's the key here. And you've got a new curve where, now at a price of 6, then, at a price of, who knows what that is, $2.50 probably. You sell 6 million hamburgers, you would have sold maybe none before, very few. $2, you sell 2 million before, and now you sell 8 million and so forth. So shift in demand. Okay, supply. we usually discuss demand and supply in the same lecture because they're defined in very parallel ways. What's going on the supply side and what's going on the demand side are actually a little different if you start digging deeper into the theory. But at this level, then the treatment of the two is very parallel. So suppliers are also assumed to be price takers. And the table, we can represent this as either a schedule or a curve. If it's a schedule, then it's a table showing the quantity supplied of a commodity at each price for a given period of time. So, and if it's a curve, it's the same thing graphically. Positively sloped curve. Positively sloped, note here. Sometimes that's called the law of supply, but that's not as ironclad of a generalization as the law of demand. Supply curves, it may possibly be able to slope down, but we won't get into that too much. Basically, for this course, you can pretty much assume supply curves are always going to be upward sloping. In fact, that's sort of a rule in economics, and there's a rationale for it, even though it's, as I said, it's not a completely ironclad law like the law of demand. But okay, supply curve for hamburgers. It's upward sloping. 2 million hamburgers a day, 50, $1, $6 million, $50, $10 million, $2, 14 million. All these points are represented here. We've got, this is probably 75 cents, 4 million. The higher the price, the more hamburgers suppliers are willing to supply. And in a sense, that does seem reasonable. It's like, oh, that's a great business to be in, the hamburger business. You can sell them for a lot. Really high demand for those. Really high prices for those. So again, price is taken, then suppliers respond. Some supply response to a given price. Okay, as with demand, there can be changes in supply. So what factors would cause the supply curve to shift? Improvement in technology is one. Reduction in price of resources. More favorable weather conditions for agriculture. This is just 3 examples. There could be lots of other examples. Changes in foreign trade or new firms entering the market. But these are probably particularly common ones. So weather conditions are a great example for just textbook problems and so on. They illustrate it very well. Reduction in the price of resources. So computer chips, oil and gas, that might make it cheaper to produce something. That will tend to make suppliers willing to supply more of it. And improvements in technology, also lower cost of production. So those all shift the supply. In fact, those would all shift the supply curve out. No, 1, 2, and 3. So less favorable weather conditions could shift the supply curve in for agricultural commodities. One subtle thing about this supply curve movement. Supply curve, is this an increase or a decrease in supply? Now, because they've drawn this arrow, it looks like more like an increase. So like, oh, okay, so the supply curve is moving away from this axis, which would be 0, so that looks like an increase in supply. But if you didn't have that arrow, you could easily look at the 2 curves and think, okay, S prime is below S. That means there's probably been a reduction in supply. No. Wrong. There's been an increase in supply. So that's a little counterintuitive, and it's something that I often see wrong on exam questions. People will say that they'll treat this as a decrease in supply because the supply curve is moving down. That's not what matters. What matters is it's moving out. Notice that if it's moving out, that means for any given price you're willing to supply more. That's an increase in supply. You don't have that problem with the demand curve because the demand curve slopes down, so that will be moving both out and up at the same time. But the supply curve, when it's moving down, so to speak, that's actually an increase in supply because it also means it's moving out. You're willing to produce more for any given price. Okay, so equilibrium price, that's where quantity demanded is equal to the quantity supplied. This is the brilliant point at the heart of economics. And then if the price is not at the equilibrium price, then you can end up with either a surplus or a shortage. So this represents it in a table. Quantity supplied per day, quantity demanded per day. Notice if the price is $2, suppliers are willing to supply 14 million, but customers only want 2 million at that price, so there's a big surplus, 12 million extra hamburgers produced. Oh no, that's terrible. All that meat going to waste. What are we going to do? We need some kind of a government intervention to prevent all this waste from happening. No, we don't. Because if the price is $1.50, then you've got a smaller surplus. If you've got $1, then you've got no surplus at all. And you don't need to intervene in the market to make this $1 apply, because if suppliers are producing all these hamburgers that they can't sell, they're going to start trying to undersell each other. That's going to drive the price down. Meanwhile, customers may also see the surplus and they start bidding, say like, hey, you guys, see you got all those extra hamburgers. You want to give me one for maybe $1.50 or $1.25? And some suppliers would be willing to do that. They might regret having made the hamburgers, but now that they're there, they'd be willing to do that. But over time, then this is going to balance out, and the market is going to find its way to this equilibrium price, where the right amount is same amounts are supplied and demanded, no waste, equilibrium. So that's a very desirable outcome. In fact, it's the ideal outcome from a social welfare point of view, and we don't have to engineer it by any special policy interventions. That just emerges from the market. That's the brilliant insight at the heart of economics. As I said like a couple times already, sorry for repeating myself, but I'm very excited about it. So, this shows it all graphically. Same thing as we just saw on the table. And I've probably... So this is all region of surplus. If your price is up here, then you get extra hamburger supplied. Here you've got a shortage, too many hamburgers, not enough hamburgers supplied, sorry. And so that's probably enough for one video.